All right, let's go ahead and take a look at lesson 9.2, solving quadratic equations by graphing. In example 1, we're going to look at solving a quadratic equation where there are two real solutions. So they're telling us here, solve x squared plus 2x equals 3 by graphing. Now the first thing we want to do is set this equation equal to 0. We can see right now that it is equal to 3. So to set it equal to 0, we're going to need to subtract 3 from both sides of this equation. This gives us the equation x squared plus 2x minus 3 equals 0, and now we can go ahead and graph this to solve. So now, since this equation is in standard form, ax squared plus bx plus c equals 0, we can go ahead and identify a, b, and c. A is the coefficient of x squared, that's going to be 1. B is the coefficient of x, that is 2. And c is the constant, that is negative 3. The next thing we want to do is find the axis of symmetry, x. And the way we're going to do that is by using the formula x equals negative b over 2a. And remember, we always want to use parentheses whenever we're substituting. So I'm going to put here negative parentheses over 2 parentheses. And then up here, we're going to put our b value, which is 2. And down here, we're going to put our a value, which is 1. So we have negative 2 over positive 2, which equals negative 1. So now we know our axis of symmetry is the line x equals negative 1. So we could take that, we come to our graph, and we could put a dotted line on the line x equals negative 1, because that's our axis of symmetry, the middle of the parabola. Now what this also tells us is the x value of our vertex. So we know our vertex is going to be at the point negative 1 comma something. We need to find the y value. How are we going to do that? We're going to substitute this negative 1 into the left side of this equation and work it out to find y. And remember, once again, always a good idea to use parentheses. So we're going to set this up like this. Parentheses squared plus 2 times parentheses minus 3. And what we're going to do is plug in this negative 1 and work it out. So negative 1 squared is 1. 2 times negative 1 is negative 2. And we bring down this negative 3. 1 minus 2 is negative 1. And negative 1 minus 3 is negative 4. So that is the y value of our vertex, negative 4. So our vertex is at the point negative 1 comma negative 4. And we can go ahead and place that point right here. So in this case, we could also place the y-intercept. Remember, when our function is in standard form, then c is our y-intercept, which is negative 3. And so we could put a point right here. Now, we've already moved off one point to the right side of this parabola. So what we're going to do is continue the right side and then reflect to get the left side. So our next x value on the right side is 1. And following that will be 2 and then 3. So let's go ahead and plug these in and see how far we need to go. So first, let's go ahead and find the point 1 comma something. So we're going to plug in a 1 here and work this out. 1 squared is 1. 2 times 1 is 2. Bring down the negative 3. 1 plus 2 is 3. And 3 minus 3 is 0. So our y value is 0. So one of our points is 1 comma 0. Let's go ahead now and do 2 comma something. So now we're going to plug in a 2 here and work this out. 2 squared is 4. 2 times 2 is 4. And we bring down this negative 3. 4 plus 4 is 8. And 8 minus 3 is 5. So we have the point 2 comma 5. Let's go ahead and place those. So we have 1 comma 0, that is right here. And we have 2 comma 5, that is right here. And that's good enough. Now what we're going to do next is reflect to get the left side. So this point here is 1 step to the right. So its partner on the other side will be 1 step to the left of the axis of symmetry. This point here is 2 steps to the right of the axis of symmetry. So its partner will be 2 steps to the left. And this point is 3 steps to the right of the axis of symmetry. So its partner will be 3 steps to the left. And so here is our parabola. I'm having a hard time graphing these perfectly, but you get the idea. And our main focus in order to solve this equation is the x-intercepts. We're looking to see where this graph intersects the x-axis, which is at these 2 points right here, +1 and -3. So those are our two solutions, x equals 1 and x equals -3. So what you can see here is if we take these two x values and plug it into the original equation, it will make the equation true. So we have here x squared plus 2x equals 3. And first let's go ahead and plug in 1. So we have 1 squared is 1, and 2 times 1 is 2. And 1 plus 2 equals 3. So we end up with 3 equals 3. On the other side, we can do the same thing again. X squared plus 2x equals 3. And this time, let's plug in -3. -3 squared is 9. 2 times -3 is -6. And 9 minus 6 is 3. So once again, we end up with 3 equals 3, which is true. All right, so now go ahead and pause the video. Try to find the solutions to this problem here, and then unpause the video and see if you got it right. All right, so we have here x squared plus 7x equals -10. Once again, this equation is not set equal to 0, and that's what we want. So we have to get rid of this -10, so we're going to add 10 to both sides of the equation. This gives us x squared plus 7x plus 10 equals 0, and now we can go ahead and graph it. Next, let's go ahead and identify a, b, and c. Our a value is 1, our b value is 7, and our c value is 10. And now let's find x. Remember, using the formula, x equals -b over 2a. Once again, I'll repeat it every time. Whenever you do substitution, use parentheses because it keeps you from making mistakes. So our b value is 7 and our a value is 1. So we end up with here -7 over 2, or let's call that -3.5. So that is where our axis of symmetry is at the line x equals -3.5. So we could come here and we're going to put our dotted line in between -4 and -3. That is where -3.5 is. And remember that this -3.5 is the x value of our vertex. And what we need to do is find the y value of our vertex by plugging -3.5 for x into the left side of this equation and working it out. -3.5 squared is 12.25. And 7 times -3.5 is -24.5. Then we bring down this +10. And 12.25 minus 24.5 plus 10 is -2.25. So that is the y value of our vertex. So that's going to be right about here. And we can see again here that we can place our y-intercept, which is 10. So that's going to go way up here. And we're on the right side of our parabola, so we could continue working on the right side. We're not going to bother to do -3 because that's really close. So let's just do -2 and -1 as our x values. So first, let's figure out what is y when x is -2. We're going to plug in -2 here and work this out. -2 squared is 4. 7 times -2 is -14 plus 10. 4 minus 14 is -10. And -10 plus 10 is 0. So when x is -2, y is 0. Now, how about when x is -1? So we're going to plug a -1 in here and work this out. -1 squared is 1. 7 times -1 is -7. We bring down the plus 10. 1 minus 7 is -6. And -6 plus 10 is +4. So our other point is -1, 4. Now let's go ahead and plot these. We have -2, 0 and -1, 4. And we already have 0, 10. So now let's go ahead and get the left side of our parabola by reflecting. So this point here is 1.5 steps to the right of the line of symmetry. So its partner is going to be 1.5 steps. to the left. This point is 2.5 steps to the right, so its partner will be 2.5 steps to the left. And this point is 3.5 steps to the right, so its partner will be 3.5 steps to the left. And my shaky hand to go ahead and graph this. That one wasn't that bad. But again, what we're looking for is the two locations where the graph intersects the x-axis, the x-intercepts, and that's going to be -2 and -5. So those are our solutions. X equals -2 and x equals -5. All right, now let's take a look at example 2, solving a quadratic equation when there is one real solution. Solve x squared minus 8x equals -16 by graphing. Once again, let's go ahead and set this equal to 0 by adding 16 to both sides. This gives us the equation x squared minus 8x plus 16 equals 0. So now we can go ahead and identify A, B, and C and find our axis of symmetry and our vertex. So our A value is 1, our B value is -8, and our C value is 16. Then to find x, we need to use the formula x equals -b over 2a. Let's set this up with our parentheses. Our b value is -8, and our a value is 1. So -8, that becomes +8 over 2, which equals 4. So our axis of symmetry is aligned x equals 4. Let's go ahead and put our dotted line here. And now we could also use that x value to find our vertex, because our vertex is going to be the point 4, something. So we're going to substitute 4, our x value, into the left side of this equation and work it out to find y. So 4 squared is 16. -8 times 4 is -32. And we bring down this plus 16. 16 minus 32 is -16. And -16 plus 16 is 0. So our vertex is at the point 4, 0. Which shows you why there's only one real solution, because the vertex is on the x-axis. So let's just go ahead and finish graphing this real quick. Let's move off to the right. So where x is 5 and where x is 6. So we're going to plug in a 5 for x and work this out. 5 squared is 25. -8 times 5 is -40. Bring down the plus 16. 25 minus 40 is -15. And -15 plus 16 is 1. So where x is 5, y is 1. And so now where x is 6, we're going to substitute a 6. 6 squared is 36. -8 times 6 is -48. Bring down the plus 16. 36 minus 48 is -12. And -12 plus 16 is 4. So where x is 6, y is 4. Now we can place these points. We have 5, 1, and we have 6, 4, and we can reflect. This point is 1 step to the right, its partner 1 step to the left. This point is 2 steps to the right, its partner 2 steps to the left. And so here is our parabola. And once again, we can see that this graph only intersects the x-axis in one location, where the vertex is. So our solution is x equals 4. Now go ahead and pause the video and try this problem, and then come back to see if you got it correct. So we have here x squared plus 10x equals -25. Again, we need to set this equal to 0, so we're going to add 25 to both sides, giving us the equation x squared plus 10x plus 25 equals 0, and now we can graph it. Let's go ahead and identify A, B, and C. Our A value is 1, our B value is 10, and our C value is 25. Now let's find x by using the formula. X equals -b over 2a. And we're going to plug in our B value, which is 10, and our A value, which is 1. So we end up with -10 over 2, which equals -5. And so that is our axis of symmetry, the line x equals -5. So we're going to put that dotted line here. Now we also know that that -5 is the x value of our vertex, and we need the y value, so we're going to plug that -5 into the left side of the equation and work it out to find y. So -5 squared is 25. 10 times -5 is -50. And we bring down this plus 25. 25 minus 50 is -25. And -25 plus 25 is 0. So our vertex is at the point -5, 0, which is right here. And we already know what the solution is going to be. But let's go ahead and just find 2 more points going off to the right so we could finish this graph. So we have -4, something and -3, something. Let's plug in -4. -4 squared is 16. 10 times -4 is -40 plus 25. 16 minus 40 is -24. And -24 plus 25 is 1. So we have the point -4, 1. Next, we can plug in -3. -3 squared is 9. 10 times -3 is -30. Bring down the plus 25. 9 minus 30 is -21. And -21 plus 25 is 4. So we have -3, 4. So -4, 1 and -3, 4. And we can reflect. This point is 1 to the right, its partner. 1 to the left. This point is 2 to the right, its partner. 2 to the left. So there's our graph and what we already knew from the beginning. If the vertex is on the x-axis, then there's only one solution. And so our solution is x equals -5. All right, now let's look at example 3. What does it look like when we solve a quadratic equation and there are no real solutions? So it says here, solve -x squared equals 2x plus 4 by graphing. Now again, we need to set this equal to 0, but instead of moving the 2x and the 4, we can move the -x squared. We don't want a -x squared anyways, so we can go ahead and move it to the other side by adding x squared to both sides. And then we can just flip it around. If you like having the 0 on the right side, it doesn't matter. So on one side, we're going to have x squared plus 2x plus 4. And on the other side, we're going to have 0. And now we can go ahead and graph this. All right, so our a value is 1, our b value is 2, and our c value is 4. So now let's go ahead and find our axis of symmetry by doing x equals -b over 2a. So our b value is 2 and our a value is 1. So we have -2 over +2, which equals -1. So our axis of symmetry is the line x equals -1, which is right here. And we know that this x value is also the x value of our vertex. So we can plug in -1 into the left side of our equation and work it out to find y. -1 squared is 1. 2 times -1 is -2 plus 4. 1 minus 2 is -1. And -1 plus 4 is 3. So our vertex is the point -1, 3. And that is right here. Now we also know that our y-intercept is 4 because c equals 4. So we could place that point right here. And let's go ahead and get one more point to the right side. So what is y when x equals 1? So we're going to plug this 1 in here and work it out. 1 squared is 1. 2 times 1 is 2. We bring down the plus 4. And 1 plus 2 plus 4 is 7. So where x is 1, y is 7. So we could place this point here. Now let's reflect. This point is 1 step to the right of the axis of symmetry. Its partner will be 1 step to the left. And this point is 2 steps to the right. So its partner will be 2 steps to the left. And so here is our parabola And now we can understand why this is no real solutions, because we see that this parabola does not intersect the x-axis at all. All right, last problem. Go ahead and pause the video, work this problem out, and come back and see if you got it right. All right, once again, we want to set this equation equal to 0, so we're going to add x squared to both sides. And this gives us x squared plus 2x plus 5 equals 0. Now we can go ahead and identify a, b, and c. Our a value is 1, our b value is 2, and our c value is 5. Let's go ahead and find x using x equals negative b over 2a. So our b value is 2, and our a value is 1, and we end up with negative 2 over positive 2, which equals negative 1. So our axis of symmetry is at negative 1, and we can put our dotted line there. So now we can plug in this negative 1 for x and find the y value of our vertex. Negative 1 squared is 1. 2 times negative 1 is negative 2. Bring down the plus 5. 1 minus 2 is negative 1, and negative 1 plus 5 is 4. So our vertex is at negative 1, comma 4. So we put that point here, negative 1, comma 4. And we can also see that our y-intercept is 5, because c equals 5. So that's going to be right here. And once again, let's go ahead and find what is y when x is 1. So we're going to plug in 1 here and work this out. 1 squared is 1. 2 times 1 is 2. Bring down the plus 5. And 1 plus 2 plus 5 is 8. So we have the point 1, comma 8. And that's going to be right here. Let's reflect. This point is 1 to the right, its partner 1 to the left. This point is 2 to the right, its partner 2 to the left. And so once again, we can see that this parabola does not intersect the x-axis at all. So our answer is no real solution.